A single microservice failure can bring down your entire application. In this video, you're going to deploy and bulletproof many microservices using an Istio Service Mesh. I'm going to provide you with all of the project files you need to instantly visualize traffic between all the services we're going to deploy new versions of a particular service with zero downtime using Canary releases, automatically prevent cascading failures with circuit breaking, and monitor everything from a single Grafana dashboard. Whether you're running 5 services or 500, this step-by-step guide is going to take you from installation to production ready in less than 1 hour. Let's get started by downloading the project files for this demo. I'll see you in there. All right, we interrupt this broadcast with a very important message. If you haven't subscribed already, come on, hit that subscribe button. You'd be doing me a favor. All right, see you in the lesson. Inside of your video description, I left you a link to a repository that contains all the code needed to follow along with this YouTube tutorial. Or if you're the type of person that prefers to read, you can also access everything we're going to talk about in this video as an article, but definitely recommend watching the video first as I explain things in a lot more detail. In any case, there are prerequisites to follow along with this YouTube tutorial. You need to have access to a Kubernetes environment, whether that's on your local machine or whether you're accessing Kubernetes cluster on the cloud. Doesn't really matter as long as you can run kubectl commands. And you need to have Helm set up on your machine, as that's how we're gonna be installing Istio. So if you don't meet either of these requirements, check out the following links. And if you need a refresher on Kubernetes itself, feel free to check out our complete Kubernetes course. Anyways, go ahead and clone this repo inside a directory of your choice. Doesn't really matter. I cloned it in a directory called YouTube tutorial. I'll go back to that in a second. Before we install Istio, this repo contains a bunch of microservices, all of which come together to form an e-commerce application. I'll show you what that app looks like in a second. Now, if I just deploy these services, they're gonna be able to talk to each other and function beautifully. The application works. So why would we want to run them in a service mesh? Well, let's just say I suddenly want encryption between traffic that goes between the e-commerce UI and the product catalog. Let's just say that suddenly I decide I want observability. I want detailed metrics, logs, and distributed traces coming from all of these services. Let's just say I want to then implement things like timeouts, retries, circuit breaking. All of these features, typically, I would have to go into the application code itself, implement them, repackage them as containers, and then deploy them as YAMLs. So I'd have to go into the code to implement them. Well, what we can do instead is run them as part of an Istio Service Mesh that can take care of all of these things on the application's behalf. So the beautiful thing about running services in a service mesh is we get so many powerful features like security, observability, and traffic management without touching the underlying code itself. How is this going to work? Well, there's no point of me talking over an empty GitHub repo. So let's just start by installing Istio, and then I'll walk you through everything step by step. All right, we're good. So I cloned the repo inside of the following directory. I'm going to launch it inside of VS Code. You can use any text editor you want. It doesn't really matter. So I hate the new Mac updates. Let me fix that. So inside of the setup folder, I left you with a bunch of commands that you can use to install Istio. Now, usually in other videos, you're used to me explaining each command line by line, but there are just so many commands that in this video, I decided to just prepare them in advance so that we can go ahead and just copy them into our terminal. So make sure that you've got Kubernetes running. go ahead and paste this first bunch of commands. So what that's going to do is create the namespace Istio system. It's going to add the Istio Helm repository that contains all of the Istio Helm charts which we're going to use to install different Istio components. So the Istio base components, the Istio control plane, the Istio ingress gateway that's going to be receiving all inbound traffic into the service mesh that we're going to set up. So when you install all of these different components and release all of their contents into the Istio system namespace, you've essentially installed Istio and can use it in your Kubernetes cluster. So let's make sure that all the pods and services are actually inside of our namespace. Indeed, they are. Beautiful. Now we've installed Istio, but let's install some add-ons. All right. The most important add-on is Kiali, because that's going to essentially allow us to visualize everything that's happening in the service mesh, where traffic is going, how traffic is splitting, if there's circuit breaking going on, has a certain service tripped the circuit, etc. As Envoy proxy containers, the ones running alongside the application containers, as they're collecting metrics and logs, they're going to be sent over to Prometheus, which we can visualize in Grafana, and Jaeger we can use to visualize traces, and trace the life cycle of a request. So all of these add-ons are going to make our Istio experience a lot smoother. So let's go ahead and use these commands to install them. All right, we're essentially just applying a bunch of YAML files, nothing crazy. All right, so now we've got Istio all set up. What we want to do is deploy these microservices and make sure that they run inside of an Istio service mesh. How are we going to do that? Let's start by deploying the let's start by creating the e-commerce namespace. And this line is really, really special. So by labeling our namespace with the following label, Istio injection equals enabled, any service that we deploy, any microservice that we deploy to this namespace, each pod is going to have, the typical application container, whatever that container is. In this case, it's just an e-commerce UI container, just a simple React application. And alongside that container, there's going to be an Envoy proxy container. So every pod's going to have two containers. The Envoy proxy container is the one we're interested in, because that's essentially going to allow the e-commerce UI service, in this case, you can ignore all these environment variables, they're just there to make the app work. It's going to allow this microservice to be part of a much grander service mesh. Because if you think about it, a service mesh is just something that controls all the network traffic that's going in and out. If every single Envoy proxy container controls the traffic going in and out of each pod, then it follows that if every microservice has its own Envoy proxy container, then they're all going to be part of the same service mesh. And when they're part of the service mesh, we can control how traffic goes in and out without modifying any of the code. We can implement things like traffic splitting. We can implement observability, because those Envoy containers can generate metrics and logs based on the requests going in and out. We can implement resilience, all of that fun stuff. So let's go ahead and just run this command. Enough of me talking. And now, by virtue of kubectl applying everything inside of the microservices folder, so kubectl apply -f, Istio Service Mesh /microservices, by applying everything in there, it's going to deploy all the e-commerce microservices. Go ahead and say kubectl get pods -n e-commerce. There are two containers per pod, the application container itself and the Envoy proxy container which essentially allows that service to be part of a much grander service mesh. And because now it's part of the service mesh, we can implement all of these really cool features like Canary deployments, circuit breaker functionality. Let's look at that in the next section. Alrighty, continuing this recording, picking up where we left off. So here we've got the e-commerce application that's split into many microservices. All of these microservices are backends. The front end, the front door to our e-commerce app is this e-commerce UI. We need to interact with this front end in order to generate traffic that will span all of these services, which we can then visualize through the Istio Service Mesh. The Istio Service Mesh will allow us to visualize all the traffic that's going on inside of it and be able to manage it any way that we want. It follows that the entry point to our e-commerce UI needs to be an Istio custom resource, not just any ingress resource, a specific gateway resource that's native to Istio. This is very similar to any other ingress that you've defined in Kubernetes, whether that's an Nginx ingress or Kong ingress, doesn't really matter. But this one is native to Istio. And it configures the ingress gateway very simply, in this case, to accept HTTP traffic on port 80. So this will act as the front door to our cluster of applications. And we benefit from this because it's a single managed entry point for all external requests into the e-commerce UI. So after requests go through the Istio gateway, this virtual service is going to act. It's going to define how that traffic is routed. So this is essentially going to map all incoming requests that go through the gateway on the prefix / to the e-commerce UI service on its port 4000. The e-commerce UI service, if you scroll down, is accepting requests on port 4000. So ultimately, this will allow external requests to reach the entry point of our e-commerce application. All right, finally, we have this really, really interesting resource, peer authentication. You'll remember I told you that every container alongside it, there is an Envoy proxy container that's running. Every request that goes in and out of the pod will be intercepted by the Envoy proxy container. And in this case, each one is going to ensure that a request going from one service to another follows a very strict MTLs authentication. So this ensures ultimately that all service-to-service communication is encrypted, and we didn't have to write anything inside of the application logic to introduce encryption between each app. We were able to do all of this at the Istio layer in less than 8 lines of YAML config. So ultimately, MTLs, if you haven't heard of it, it's a two-way authentication protocol where both whoever issued the request and whoever is receiving it, they can verify each other's identity through digital certificates. So this provides way stronger security than the traditional one-way TLS because it ensures that both parties, the issuer of the request and the receiver, that they can trust each other's connection. So all of this is done by the Envoy proxy containers running alongside each service. So ultimately, we were able to harness encryption, service-to-service encryption, without writing any logic in our application code. All of this is happening at the service mesh level. So enough talking, let me go ahead and apply all of these manifests that live inside of the Istio folder. So, oh yes, Istio Service Mesh / Istio. Applying all of this. So now we should be able to access everything on port 80. So let me go ahead and open up Chrome. We just got to say localhost 80 or simply localhost. Beautiful. So here's the e-commerce UI. It's actually fully functional. I programmed this last year for my Docker course. If you haven't taken my Docker course, highly recommend you do if you want to really master the technology. So you get to create an account. I'm just going to create an account, Ryan, Slim, address ABC, Istio Avenue, whatever, ABC, EFG, we'll say abc@hotmail.com, password ABC. All right, let's go ahead and sign up. Took a while. Anyways, abc@hotmail.com, ABC, go ahead and sign in. And what I want you to do is just play around with the app. Try to generate a lot of traffic, okay? So go ahead and, I don't know why it's taking a while. Go ahead and make some requests. It's a bit slow. I don't know why, but whatever. Add some stuff to cart, go to your order management, place the order, go to shipping, go to profile management, okay, inventory management, so far so good. Now, let's visualize all of the traffic that's going through our service mesh of Envoy proxy containers. So what I want you to do is say kubectl get services -n istio system. And the service that we want to port forward is the one that belongs to Kiali. So we want to say kubectl port forward service /Kiali -n istio system. We'll forward the internal IP port 20,001 to our local host machine port 20,001. I think we should be good to go. All right, let's visualize what's happening inside of our service mesh. Localhost 20,001. You should get a view of Kiali. Okay, we're going to start by visualizing the applications inside of the e-commerce namespace. Notice that it says MTLs is enabled for this namespace. I'll come back to that in a second. Let me go to the applications inside of this namespace. Alternatively, you could have just clicked on this tab. And interestingly enough, we see that all applications that are part of the Istio Service Mesh are healthy. That's a very good sign. You always want to see that green check mark. We also see some interesting details over here in that peer authentication is going on between each microservice in the service mesh. Mutual encryption that we didn't have to program ourselves. We just had to declare it, and now requests between each service are now much more secure because now there's mutual certificate verification between each service. All right, so we got that for free. And you'll notice here that the e-commerce UI has an extra detail because the virtual service was applied to it, whereby incoming traffic going through the e-commerce gateway is going to start over here and then propagate to every other microservice. So because I just talked a lot, we might not actually see anything in the workload traffic visualization tab. So if we click here, we see an empty graph. So what I need to do is actually go back and play around with this a little bit more. Whatever, we'll add this to cart again, add the water bottle, add the microphone, whatever. Go back to order management, place the order, go to profile management, mess around a little bit, go to shipping, go to contact us, submit a random claim, inventory management. Okay, we're good. Pressing that a little bit more, refreshing the page, beautiful. So here we see traffic starts from the Istio Ingress gateway. The virtual service routes the request to the e-commerce UI front end, and the front end communicates that request to multiple back-end services, depending on where we need it to forward that request. And we can actually see the response times over here in milliseconds for each service-to-service call. And the traffic distribution percentages shows how much requests went to product inventory, how much requests went to product catalog, how much went to order management, so on and so forth. So here we can actually clearly see dependencies between services and how they communicate with each other. And if you specifically didn't want to just visualize it for the e-commerce UI, but wanted to drill into a particular microservice, you can do that as well. So if I just interact with Let me go ahead and submit another product, go to order management, place order, go back here. We see order management. It actually, in order to make an order, has to consult the product inventory microservice and product catalog. So it's pretty cool how, because these Envoy proxy containers are intercepting each request, Istio knows exactly where each request starts and where it ends. We can see the dependencies between order management and the other services. We can see, maybe go to product inventory. That graph is empty now. All right, that's pretty much it for visualization. In the next chapter, we're going to look at how we can implement Canary deployments with Istio. This next section of our video is going to discuss Canary deployments, something that we can very easily implement when our services are part of a mesh. So here we have our product catalog deployment, which runs well. It's able to process thousands of requests, but we recently decided to upgrade it to version v2, which processes requests and interacts with a MongoDB database. But we're scared of just outright deploying v2 because we're not sure if it's going to be able to handle the same load as v1. Is it going to fail when it starts getting too many requests? Is it actually going to function? So what we want to do is implement a Canary deployment where we deploy version v2 of product catalog. So version v2 right over here, the one that connects to a MongoDB database, but we only direct 20% of the traffic to version v2 and 80% of the traffic to version v1. And at a certain point in time, once we're certain that version v2 is able to handle all that traffic, we slowly increase the load until we're ready to forward all of that traffic to it. All right, pretty cool stuff. Now, I don't want to simply skip through these two manifests because they're very, very important. So VirtualService, this is the second time you're seeing it. So let me just kind of define what a virtual service does generally. So this is used to define traffic routing rules that control how traffic requests are routed to their destinations. So ultimately, this routes 80% of traffic to go to the version v1 of our product catalog microservice and 20% to version v2. Now, this virtual service relies on subsets in order to implement its traffic routing rules. Where do these subsets come from? Well, we see the name pop up over here inside of this destination rule. How does it work exactly? Let me just take a step back for a second. Don't be intimidated. Let's go back to the product catalog. So this cluster IP service sends traffic to any deployment or pod that has this label app product catalog. v1 of our product catalog has this label, as we can see over here, and v2 of product catalog has this label. All right. It follows that the destination rule is going to find all pods that are selected by the product catalog cluster IP service. So this pod, and it's going to look at their corresponding labels. The ones that have a label version of v2, in this case, put them in the subset v2. The one that has a version of v1, the one right over here, put them in the subset v1. So now that we have the subset, now that we've isolated our pods into distinct groups, we can use these groups in order to target them differently when routing traffic within the virtual service. So that's ultimately how these two work together. Destination rule lets you organize your pods into versions or groups so that we can target them differently when routing traffic inside of the virtual service. All right, so the only difference is this deployment has a different label, version v2, because ultimately it was programmed to connect to a MongoDB database, which is being specified here. Again, we don't care about the MongoDB database and its corresponding service. We just care about the product catalog v2. All right, let's go ahead and implement this. So stopping that, we'll say kubectl apply -f. Let me put this over here. Istio add-ons, not Istio add-ons, Istio Service Mesh / Canary, you can't see that, / Canary deployment. Adding all of these. Let's say kubectl get pods -n e-commerce, making sure that is being set up. So the MongoDB database that product catalog v2 relies on, it's still initializing. We'll give that a second. Okay, perfect. Now let's go ahead and port forward Kiali again. We'll go back to our Chrome session, interact with our application once more, go to the product catalog, add to cart, play around with the product catalog, so on and so forth. So note now that we have two versions of our product catalog running. Some requests are being routed to version v1, other requests are being routed to version v2. Okay, now go to order management, place the order. Now if we go back to Kiali to visualize everything that's going on, go back to applications, go to e-commerce UI. So here we've got the initial virtual service that processes all requests coming from the gateway into our entry point, the e-commerce UI. And here we've got the virtual service we just worked on, the one that splits traffic between version v1 of our product catalog and version v2. Here we can see that most requests are going to version v1, specifically 87% of requests and 12% are going to version v2. So going back over here to applications, here we can see our product catalog, version v1 and version v2. That's all we're going to cover for Canary deployment. Now we're going to cover circuit breaking. In this section, we're going to implement circuit breaking, a very powerful feature that everyone should have implemented in production. Why? Let's say you've got an order management microservice that's functioning really well. You're getting thousands of requests an hour to it. It's processing all the requests beautifully, making orders, but then suddenly you decide to deploy an update, version v2 of the order management microservice. Now, for some reason, everything worked really well in dev, but then when you deployed to prod and requests started flowing to it, it just always failed, started getting a lot of errors. Your users were very frustrated because the app isn't working anymore. But then no matter, because you happen to have a circuit breaker implemented as well, and when a circuit breaker sees that flood of errors, it's going to trip the circuit. It's going to break the circuit of requests that are going to version v2 and redirect everything back to the functional version v1 so that your users are able to make successful requests again and be happy with the experience. Okay, so now we're going to implement circuit breaking, and the setup for this is very similar to the one we had for the Canary deployment section, mainly because we're still performing a Canary deployment, but we're adding some extra protection rules. Okay, so let me just step back a little bit. So now we're going to be deploying order management v2. Now what's worth noting is this label, which establishes order management v2 as well as order management v1 as valid targets for the order management cluster IP service. Okay, so this cluster IP service is going to select any app that has this label as a target for receiving traffic. So really important that we have that so that we can then go in the destination rule and find any pods that are targets of the order management cluster IP service and any ones that have a version of v2, put them in the subset v2. Any app, any target that has the version v1, put them in the subset v1. And now that we've isolated our pods into distinct groups, we can apply traffic routing rules on them such that 80% go to v1 and 20% go to v2. But now we go a step further, and after our traffic has been routed, we can implement some protection rules, because the destination rule is responsible for how we treat traffic after the routing decision has been made. All right, so this one isn't really related to circuit breaking, but it's good to have in our traffic policy because it basically says our order management service is only allowed to have 100 TCP connections at a time. If we go above that, we either put other requests on pending or we outright reject them. We can only have 10 pending requests at a time. Anything above that, reject. And this says we can only have 10 HTTP requests per TCP connection, a very low level networking configuration, which ultimately ensures that a single TCP connection doesn't last for too long because that can ruin load balancing. You also don't want to make this value too low because not after every request do you want to open a new connection between the client and the server. So 10 is usually a good compromise. But what I really want to point you to is the part that's actually responsible for circuit breaking. So these are all performance-based configurations that we don't really care about right now. What I care about for this chapter is the circuit breaking portion. If a pod, be it belonging to v1 or to the subset v2, returns 5 consecutive HTTP 500 errors, so server errors like 501, 502, 503, etc., Istio is going to mark that pod as unhealthy and temporarily remove it from the load balancing pool, effectively blocking any traffic from going to it. And it's going to eject that pod from the load balancing pool, and the base ejection time is 30 seconds. So it's going to stay out for at least 30 seconds, and then in intervals of 30 seconds, Istio is going to keep checking for these error patterns and determine whether or not the circuit breaker should be triggered. Okay, so what we're going to experience is, at first, we're going to be receiving a lot of errors because order management v2 is faulty. But then once the circuit breaker gets triggered, we're not going to see any errors anymore because traffic is going to be blocked from going to v2 and everything is going to go to v1, which actually works. So let's go ahead and visualize this in real time. So kubectl apply-f will apply what's inside of Istio Service Mesh. You can't see that, / circuit breaker. All right, let's say kubectl get pods -n e-commerce. Okay, order management v2 is running. Let me make sure of this. Go to applications. Let me restart Kiali. Okay, so in Kiali, all of our applications seem to be healthy. Pod status for order management 1 and v2, they're good. Here's what we can expect. When I go to my product catalog and add things to cart, we should experience some bugs and glitches as we interact with the application. So right now it's interacting with v1, that's why everything is flowing smoothly. This one interacted with v2. That's why the request stalled, and we should eventually get an error here in a bit. Now it tries to access order management v2, which returns back an empty response. And now at this point, we've done enough to trip the circuit. So if we go to workloads, order management v2, here we can see the circuit breaker sign, which is blocking any requests from going to v2. Beautiful, because it determined all inbound traffic going to order management v2, 100% of them have been unsuccessful. All right, so now because of the circuit breaker, if we try to use the app now, so here we get all these errors that are coming now because other requests were stalling. If we try to use it now, it's only going to make requests to v1, which proves that our circuit breaker is functioning beautifully. All right. So that's pretty much it. When it determines that a certain pod is experiencing a lot of errors, it's going to block any traffic from going to it. So circuit breaking, that's pretty much it. And you can tell circuit breaking is happening by the red line over here, such that requests going to here have stopped, and the remaining requests are going to be redirected through this green healthy path going to order management v1. All right, and now let's finalize everything by monitoring our service mesh with Grafana. So let me go back to my terminal, and I'm going to say kubectl get services -n Istio system. The service that I want to port forward is Grafana. So kubectl port forward the Grafana service in the namespace Istio system. And I want to port forward cluster IP port 3000 to my host machine port 3000. Pods Grafana not found. I need to specify that this is a service. Okay, now let me go to localhost 3000. And here we can see that there are a lot of pre-configured Grafana dashboards. So as these Envoy proxy containers are controlling requests going in and out of each pod, they're also recording important metrics that we can visualize in Grafana in some pre-built dashboards for the Istio Service Mesh. The most interesting dashboard is the Istio workload dashboard, because this allows you to look through individual workloads like the e-commerce UI, who experienced 78% successful requests, because as you saw before, we had some microservice versions that returned 100% success rates and other microservice versions that returned 0% success rates. And the average percentage success rate, because e-commerce UI is the entry point, is aggregated into 78.6. So pretty cool that this allows us to compare traffic patterns between different versions of each service. You're welcome to go through these dashboards on your own and see how they may benefit you in your monitoring process. You've also got the Istio control plane dashboard, which allows you to visualize performance statistics at the level of the Istio control plane, so resource utilization, discovery service metrics, so on and so forth. Let's finalize the video here. If you benefited from this, feel free to hit that subscribe button, and I will see you in the next one.